when it comes to storage classes, so there are 4 types of storage classes in C. First one is called auto storage class. Second one, static storage class. Third one, register. And fourth one, external storage class. So we have 4 types of storage classes. So what is the purpose of storage classes? Actually, the storage class will describe several characteristics. Like when you are talking about several characteristics, what a characteristic is going to describe? The first characteristic is called scope of the variable. If we consider variable I, so what is the scope of that variable? Okay, for example, in C programming we are declaring int I. So the moment if you declare the variable I, whether it may be outside of all functions or it may be inside of some function, then how many functions can access that variable? So that is called scope of the variable, means the region where the variable is accessible and available is called scope. And afterwards, second characteristic is lifetime of that variable. Means the moment when you declare any variable, how long that variable will be residing in the memory? Will it available till completion of the whole function or till completion of the whole program? If the variable is available till completion of the whole function, that is called function lifetime. If the variable is available till completion of the whole program, that is called programming lifetime. Clear? So that is called lifetime of the variable. And afterwards, third characteristic is what is the default value of that variable. In C programming, there are 2 types of default values. Either it may be garbage value or it may be 0. So what type of variables are having value 0 and what type of variables are having default values or garbage values? Next one is storage area. Storage area. So in order to discuss these 4 characteristics, we need to understand the storage classes concept. Okay. Suppose the variable is auto variable. So auto variable, what type of scope it is having? It is having function scope. Auto variable is having function scope. Means the variable is accessible only within the function where it is declared. No other functions can access auto variable of the some other functions. Okay. So this is called function scope. For example, if I consider 2 functions like f1 function block and f2 is another function block. Here if we declare auto int I, only this function f1 can access that variable I, f2 cannot access that variable. So it is called function scope. Similarly, lifetime is nothing but how long that variable is residing in the memory. If it auto variable, it is having function lifetime. Means whenever operating system is calling function call, so its activation card is loaded into the stack. As long as it is executing that function, the variable is residing in the stack memory. Once the function execution is completed, that variable will be deleted. Okay, so that is called lifetime of the auto variable. What is the default value of auto variable? That is called garbage value. And storage area, it is stored into stack memory. So we have 3 areas where the variables are residing. One is stack, another one is static, another one is heap memory. So auto variables will be stored into stack memory, friends. Okay. Next one, static variable. What is scope of static variable? The static variable is also having function scope. Static variable is also having function scope. What about lifetime? Static variable is created during compile time of the program and it will exist till completion of the whole program. Clear? So therefore the lifetime of the static variable is program lifetime. It will always hold the previous stage values. That is the reason static variables keep on updating. Whereas auto variable every time recreated and reinitialized. And what is the default value of static variable? Default value of static variable is 0. And the storage area, it is stored into static memory. As I mentioned, there are 3 sections like stack, static and heap. static variable will be stored into static memory location. Next on register variable, it is same as auto variable. Whatever characteristics auto variables are having, same characteristics are there in register variable. Then what is the difference between these two means only accessing point of view there is a difference. Suppose if you declare a variable as a register variable, then that register variable probably it will be stored into the register. If there are some free registers are available, if free registers are not available, again it will be stored into the RAM only. Clear? It means if the local variable, it will be stored into the stack. So therefore, what type of scope it is having means it is having function scope and lifetime of register variable, again function lifetime, and default value of register variable, that is garbage value. Storage area, it is stored into CPU registers, provided that there is a space available in the register. If register space is not available, it will be stored back into RAM only. Okay. So that is third storage class. Next, it is called external storage class. We can also call global variable prototype. They are called global variable prototypes. Right. So in global variable prototype, what is scope of the global variable? Global variable can be accessible across all the functions. Okay, but provided that there is no local variable with the same name of global variable. Suppose if there is any name conflict occurs between local and global, it is always giving preference to local variables only. Therefore, the scope of the global variable is program scope. And what about lifetime of global variable? So the lifetime of global variable is program lifetime. Next, default value of global variables, that is equals to 0. Storage area, we can say it is static storage area. Under static storage area, as I mentioned, memory is divided into 3 sections, right? Okay. Under static storage area, bottom part is reserved for only global variables. Okay. So these are the 4 characteristics of the storage classes: auto, static, register, and external storage classes. Okay. Then what type of questions we can expect from this topic? First, let me write the syntax for each and every variable also. Auto variable, generally we are using syntax like this: auto, and then data type, suppose integer, and variable declaration. Similarly, static variable, we can declare like this by using keyword static int x. Register variable, we can declare in this way: register int x. So global variables will be declared on top of all function blocks. Clear, friends? Okay. And if you want to access global variable across all the functions, but global variable defined somewhere else in the program, in that case we can use external keyword. Anyway, I will discuss programs also. Okay. Then what kind of questions you can expect from the storage classes? Just revise the previous year grade questions, you can understand. They are combining most of the static storage classes with the recursion concept. They are combining most of the static storage classes with the recursion concept. Clear? So let me explain different types of model questions in storage class. The first way of asking question, they are combining storage classes with control statements. Control statements and storage classes. So what do you mean control statements? In the program, they are combining storage class behavior with the conditional statements or control statements. For example, they are combining static storage class under if condition, or they are combining static storage class with while loop conditions. They are combining storage class concept with for loop condition. Okay, sometimes they are using switch case also. Okay, so we need to practice all these conditional and control statements. Okay, second one, second model of asking questions, recursion and storage classes. Recursion and storage classes. That's all. These are the two different models of question they are frequently asking the gate paper. So the moment when you see any gate question based on storage class, first verify is that storage class concept combined with the control statements or not. Okay, it may be combined with if conditional statements, if or while loop or for loop or switch case statement like that, or else verify is this program based on recursion concept or not. Okay, so these are two important models where they are frequently asking storage classes, friends. Let me explain first one. Yeah, just observe this one. This is actually one of the PYQ question. Just I change the variable names. Okay, just I change the variable names. It is not a different question. One of the PYQ question only. Just I change the variable names and values. See, the moment when you see this program, you need to understand the concept is here. Static means storage class concept, where storage class concept they are combined with the loops, right? As I mentioned, storage class concept they are combined with the control statements, right? So therefore, here they are testing student knowledge whether the student able to understand control statement along with the storage class concept or not. That is the main objective of asking these questions. So you know that question paper has been categorized into four types. So in the classroom also explained, right? So your question paper consisting of four types of questions. Like one is recall based questions. Generally, recall based questions will start with the word WHAT. Like what is the time complexity of Bellman-Ford algorithm? In GATE 2012, they asked this question. What is the time complexity of Bellman-Ford algorithm? Means the question is starting with WHAT. That is called recall based questions. Clear? Next question, like if you take like which of the following sorting algorithm having lowest worst case time complexity. So this question asked in the gate paper, which of the following, means if the student able to remember the concept of sorting, you can easily answer without putting more efforts. Okay, or the question may be starting with the word match the following. Match the following. So these three types of questions comes under recall based questions. Very simple topic these questions. Okay, so definitely your gate paper consisting of 25 marks under recall based questions from various subjects. Clear, friends? Okay, so next one, after recall based question, the second category where they are asking questions are analytical based questions. Analytical based questions. Here also they last 25 marks. And third category, that is application based questions. Here they are asking 25 marks. And the fourth one, that is equals to comprehensive based questions. If you refer your gate information brochure, in the information brochure itself they mention this point. Okay, I think page number, I didn't remember page number, but they mention like that. Okay, they have to divide the questions category into four types: recall, analytical, application, comprehensive based questions. So analytical based questions means, suppose you are having idea about the topic. Okay, we need to analyze in depth. For example, if you take merge sort algorithm. So merge sort algorithm, suppose if there are 24 keys are there, for 24 keys for sorting merge sort will take 36 seconds. Then for sorting 44 keys, how much time it will take? Means these type of questions comes under analytical based questions. If student is having complete idea analysis of the merge sort, then only can solve this type of question, friends. Okay, and application based questions, you never find this question in any textbook. They created by themselves only. Okay, so these are applications based questions. Next one is comprehensive based questions. They will combine one or two topics in a single question. They will frame the question. For example, this question comes under comprehensive based question. How many concepts are there in this problem? So in this problem we are having functions concept and storage class concept, and also we are having control statements concept. So this type of questions comes under comprehensive based questions, friends. Okay, I hope you are not writing any notes, right? Because recorded version also will be provided, so therefore you can go through it if you want. Next, see, in this problem they are using for loop condition within the main function, right? So how many times this loop is executing? Exactly, it is executing 3 times. The program is executing this way, that is under main function. So under main function, I am calling function f. I am calling function f based on the value of I, right? So whenever, if I create the variable like I value and then j value, right friends? So here I is initialized to 1 first time. I is initialized to 1 first time. Therefore, it is calling f of 1. Whatever it is going to return, that will be stored into j. Whatever it is going to call, that will be stored into j. Clear friends? Okay. So the moment if I call this function, then control will be transferred to the called function by sending the value of I that equals to 1. Right? You also try simultaneously and compare your answer with my answer. Okay. I am not giving time for evaluation. Okay, because it is a revision class. I need to cover more number of topics. You also try by yourself and compare your answer with my answer. So when I pass I equals to 1, this is called formal parameter, friends. Generally, formal parameter will be stored into stack memory location. Therefore, the formal parameter I will be created. I is equals to 1. Afterwards, what about the static variable? The static variable is created during compilation time itself only. During compilation time itself only. So when we compile the program, program having 2 stages, compilation stage and then runtime stage. Compilation always starting from topmost instruction. First, if we compile the program, this is the first line to be compiled, right? After compiling this line, we are compiling static int x is equal to 0. Then because of static keyword, this variable will be stored into static memory. Then after compilation process is completed, execution process starting from main function. So who is calling main function means operating system. So therefore, whenever operating system is calling main function, when operating system is calling main function, that main activation code loaded into the stack. That main activation code will be loaded into the stack. So in fact, stack is looking like this. Suppose as I mentioned, there are 3 types of sections here. The bottom section we are calling it is static memory. Static memory. On top of that static memory, we are having 2 more sections. One is called heap. Okay, another one is called stack. Clear friends? Okay. So whenever operating system is calling main function, that main will be loaded into the stack memory. So therefore, main activation code will be loaded into stack. Main activation code will be loaded into stack. Then what about the static variable? Static variable will be residing into the static memory. Static variable will be residing in the static memory. So therefore, here we are having 2 sections. I hope my font and everything is visible, right? Okay. Give me 1 minute time. I'll write once again. The main constant is space constant actually. Right. When you compile the program, first this piece of code will be compiled successfully. Afterwards, it will be converted into machine code. So during compilation time, the static variable is created into static memory. So assume that this is a static memory block which is created for the program. Therefore, f function got created here. Here we are having static variable that is x. But by default, static variable is having value is equals to 0. Default value must be 0. Right friends? Afterwards, main function also compiled successfully and it is converted into machine code. That machine code will be stored into static memory. So this will happen during compilation process. After compilation process is completed, then execution process starting. Execution process starting from main. right? Whenever operating system is calling main function loaded into stack memory. So this is called stack memory and heap memory. Heap and stack continuously growing in opposite directions. Therefore, whenever operating system is calling main, these variables, whatever variables we created, these variables are stored into stack memory. So I will be created into stack memory. J also will be created into stack memory. But what is the default values of I comma j? They are containing garbage values because they are auto variables, right? Then afterwards, when I equals to 1, so I am initializing I equals to 1. That's what I am explaining here. So I equal 1. These two variables are stored into stack memory, friends. Okay. Afterwards, I am calling function f, then control will be transferred to the called function. This activation record will be loaded into stack memory. So therefore, f of 1. This variable is called formal parameter. You know, formal parameter will be stored into stack memory. Therefore, create formal parameter now. Int I equal to 1. Then you may ask the questions, our main function is having variable I and f is also having variable I. Yes, we can declare variables of same name in different functions, because as I mentioned, auto variable is having function scope. Function scope means this variable accessible only within this function. This variable will be accessible only within that function. No other functions can access it. So that's why it is having function scope. Clear, friends? Okay. Afterwards, what about the static variable? During compilation time already created, then while you are running the program, during runtime, it will be, this line will be skipped and next line will be executed, because initialization also happen, x is equal to 0 already happened, right? So therefore, during runtime it will be skipped and it will execute like this, x is equal to x plus I. So x is equal to x plus I means x is equals to here 0 and I value is equals to 1. So therefore 0 plus 1, that equals to 1, friends. Okay, x value equal to 1. Afterwards it will return x. So therefore return x. So return x means the value of x is equals to here 1. It is giving back value equals to 1. So that 1 will be copied into j of the main function, right? So whenever function is returning its value back, the activation record created function automatically deleted from the stack. It is no longer available. It means that the stack will be deleted. Okay, this activation record will be deleted. Clear, friends? Okay. Afterwards, control coming back to this place. Now, where control will come back? If you return the value of x, it will go back to the main function like this, main function. So the value of x which we return, that equals to 1, right? 1, that is copied into j. Afterwards, we are taking next step. It is a for loop condition, right? For loop, first step is initialization, second step is testing the condition, third step is incrementing value of I. Next, I want to increment the value of I. Value of I will be incremented in the main function. Therefore, in the main function, I plus plus means it becomes 2. Right, friends? Okay. Now, again check the condition 2 less than or equal to 3. Yes, true. Therefore, I am calling function second time. J is equals to f of 2. Right. When I call with second time 2, again new variable I will be created. So, let me create here new variable. There is a function f, the new variable I will be created, right? So, what is the value of I now? I is equal to 2. So, let me create I equal to 2. But is this variable recreate and reinitialized? No, static variable never recreate and never reinitialized, friends. Okay. So, therefore, second time also it will be skip this line and x equal to x plus I. X means the previous static variable value. What is the previous static variable value? 1. Therefore, x is equal to 1. I value just now we passed, that is 2. So, 1 plus 2, that equal to 3. Therefore, this statement, this function will return x value as 3. So, the moment it return x value, this activation code also get deleted. It is no longer available. Right, friends? Okay. So, after deleting, we can remove this one. Then the 3 will be copied into j. So, j is equal to 3. Right? J is equal to 3. So, afterwards control came back to here. Now, again I plus plus, I value get incremented. So, I value becomes 3 in main function. Right? Now check the condition 3 less than or equal to 3. Yes, true. Therefore, same story will be repeated. I am calling function with the input is 3. J is equals to f of 3. Right. The moment if I call this function, another activation got to get created now. That equals to f of. Therefore, new variable I get created. I is equals to 3. Right, friends. But is this static variable recreated? No, it is not recreated, not reinitialized. Then x equal to x plus I. So x equal to x plus I means here x value is equals to right now, which is static variable, whose value equals to 1. Right? 1. No, sorry, I didn't update x value, right? So where it is x value, static variable value here. I didn't update earlier. X value equal to 3 here. Right, friends? Okay. So x plus I, x value equal to 3 and I value equals to 3. 3 plus 3, that equals 6. Now x is updated to 6. X is updated to 6. Afterwards, it will return x value. Return x value equal to 6. So the moment if you return x value 6, this activation got also deleted, friends. It is no longer available. Okay. So that return value will be copied into J. Now J is equal to 6. Right, friends? Okay. After that, again I will be incremented, I plus plus. So I plus plus means I value equal to 4. Once I value equal to 4, 4 less than or equal to 3 condition fail. Therefore, it will come out of the loop. So at the end of the execution, what is the content of J it is having means that equal to 6. So after returning, this activation got also deleted, main activation got also deleted. From here, control go back to the operating system. Then this activation got also will be deleted. This activation got also deleted. That's all. So what are the concepts involved in this problem? In this problem, the concept involved is static storage class and also control statements. Then what type of questions we can expect from this problem? One way of asking question, they may ask what is the time complexity of this program? What is the space complexity of this program? Okay. See what kind of questions you can expect from this explanation. I know it is taking more time for explanation. Okay, because my teaching style methodology like this only, even it is a revision class. Let me explain what type of question you can expect, friends. Okay. The first one is you need to understand what is the time complexity of this program. The time complexity of the program depends on whether it is using iterative loop or it is using recursive function. Okay. So in this problem, it is taking iterative loop, right? Iterative loop. Suppose in this problem, if I replace this value, with n, so indirectly I am covering algorithm subject here itself only. Okay. If I replace I less than or equal to n here, okay, I less than or equal to n. So what I am trying to say, suppose in the place of I less than or equal to 3, if I take I less than or equal to n, where it is incrementing step by step only, where it is started at 1. It means this loop is running exactly n times. In simple for loop, as we discussed in the classroom, there are 6 different models are right. Okay. So first model is I value incrementing step by step. If I value is incrementing step by step, it will take at most n steps. Therefore, the time complexity for this problem is order of n or theta of n. The time complexity for this program is theta of n or order of n. Generally, we are expressing tight bound. Tight bound means theta. So therefore, it is theta of n because this loop is running theta of n time. Clear, friends? Okay. Then what is space complexity of this program? What is space complexity of this program? The space complexity is depth of the recursion tree. If you observe depth of the recursion tree in the stack, so depth of the recursion tree means, for example, see how maximum depth of the recursive stack here. Maximum depth of the recursive stack. One activation required for main, another activation required for f. Clear, friends? Okay. One activation required for main, another activation required for f. After completion of first function call, this activation got deleted. Then next activation code will be loaded into the same location. Afterwards, that activation code also will be deleted. Third activation code will be also loaded into the same place. Therefore, your stack cannot grow more than beyond 2 activation records. Okay, your stack cannot grow beyond 2 activation records. Therefore, 2 activation record is nothing but constant space. Therefore, the space complexity for this program is equal to theta of 1, friends. Theta of 1. Repeating once again, space complexity depends on how much maximum depth of the recursion stack is there. So depth means it is growing maximum 2 activation records. Okay, at any point of time, if you take snapshot in the activation current, then maximum number of activation current in the stack is only 2. That is your space compress, that equal to theta of 1. Okay, so based on last year question 2024, they are asking sometime activation tree also. Activation tree means how the program is executing. Draw the activation tree. Activation tree means this one only, main function first, right? Afterwards it is calling F1. After completion of F1, again it is calling F2. So this kind of activation tree questions also they are asking. That's all. This is the first model which I explained, where in the problem storage class contains control statement, friends. Okay, control statements. So we covered this problem. So for loop question, similarly we can discuss while loop question also and switch case statement also. Let me focus more number of questions. Yes, here we are having condition statement, right? If condition. So based on if condition also, this is also one of the pre-key question, gate question, friends. Okay, just I change the values, that's all. Okay, just look at this problem once. The moment if you see this problem, here it is static storage class. Static storage class they are discussing within if condition, right? Here you need to understand how exactly flow chart of if condition will be executed. Okay, if the condition is true, we can execute the statement. Otherwise, rest of the statements following that condition will be executed. Right? You take 1 minute and try this question. After I'll explain. See the structure of this program, friends. If this condition is true, we can return the statement. Okay. If the condition fails, subsequent statement will be executed. Here the beauty of this program is return statement itself contain recursive function. Return statement is contain recursive function, right? So this program contain many topics, storage classes and then conditional statements and also recursive program, right? Let me start the program. Return value of f of 4. So we are calling function with the input is 4. The moment if I call this function with input is 4, this variable is known as formal parameter. Formal parameter residing inside the stack. Therefore, n is equal to 4 will be created. N is equal to 4 will be created. I will explain space complexity for this program also. That's the reason I want to draw the diagram. So when I call function, f of 4 activation card is loaded into the stack, right? So where n is equals to 4. N is equal to 4. Then what about static variable, friends? You know static variable created into static memory location during compilation time itself. So during compilation time, when you compile this program, the static variable will create into static memory location. A function. This is called static memory. What does static memory contain? All static variables. Therefore, we are having static variable that equals to x. X is equal to 3. They already initialize value is equal to 3, friends. Okay, x is equal to 3. Afterwards, when you are running this program, operating system is calling main is calling function f. Then we are calling f with the value is equal to 4. Therefore, f activation code will be loaded into the stack. So this part is called stack. Right, friends. Okay. Now check the condition n greater than or equal to 81. So 4 greater than or equal to 81 condition false. The moment condition false, we can skip this line. We can skip this line because this is the only statement related to if condition by using flow chart of if condition, friends. Okay. Then subsequent statement will be executed. If the condition fail, this statement will be ignored, but subsequent statement will be executed. So n equal to n star x, n is equal to 4, and whatever x value, x is equals to 3, right? So therefore n equal to n star x, so 4 into 3 that equals to 12. Afterwards x will be updated, x plus plus, so 3 becomes 4. 3 becomes 4. Now here is a return statement and it is a function call. According to operator precedence table, function call will have high priority. So therefore first we need to call function with the value of n. The value of n. So what is the current value of n? 12. 12. So therefore I am calling function with the input is 12 like this. When I call function second time, again new formal parameter n will be created. So create new formal parameter n. Now you tell me, suppose if new variable got created, what is status of previously created variable? Is it available in the stack or not? Yes, it is available. If new variable n get created, now what is status of previously created variable? Yes, it is available. So why it is available? Because auto variables always having functional lifetime. Just observe, your control still in the function only, right? Still in the function only. Since your control is still in the function, it is rotating. That's why that variable is available, friends. Okay, we are not coming out of the function, right? So therefore, it is calling f of 12. There is statement is called return statement. It will be executed afterwards. Now, if I call this function, again new variable n will be created. N is equals to 12, right? N is equal to 12. So afterwards, static int x is equals to 3, but static variable is created only one time, right? Static will create only one time. Therefore, it is not recreated, not reinitialized. Therefore, it will skip this line, it will execute this statement. N greater than or equal to 81, 12 greater than or equal to 81, condition is false. Okay, therefore, you can skip this line. So, n equal to n star x, n means here 12, whatever x means here 4. So, that equal 48. So, n is updated to 48, friends. Afterwards, x plus plus means 4 becomes 5. Becomes 5. So, next I am calling function with the input is f of 48. Again new variable n will be created, n is equals to 48, right? Now check the condition, return f of 48. Again new variable n will be created, n is equals to 48, right friends? Okay. Now this variable is not recreated, not reinitialized. Verify 48 greater than or equal to 81. Yes, 48 greater than or equal to 81 is condition false. Therefore, skip this line. Then n equal to n star x. What about x here? X is equals to 5. So therefore, 5 into 48, which is equals to 240. N is updated to 240. I don't know whether it is visible or not. Right friends, okay. After making n is equal to 40, now make x equal to x plus plus. It means that x is equal to 6. Then again I am calling function with input is equals to 240. That is return f of 240. So first input value is equals to 4, next one is 12, next one is 48, right? Next one is 240. When I am calling with 240, n is equal to 240 will be created. 240. Create another activation record, f of 240. Right? Now check the condition 240 greater than or equal to 81. Yes, condition true. Therefore, return n. Fourth time it is going to return n. So what is the value of n? N is equals to 240. So it will return 240 to the previous level. It will return 240 to the previous level. Then this activation card will be deleted from the stack. Right friends, okay. Means from the stack we have to delete this corresponding activation record. Then afterwards control go back to this place, because there is a return statement, right? There is a return statement. So because of this return statement, return from 240 to the previous level. Then this activation card also get deleted. So delete this activation card. Means you always think like this. It is passing value equal to 240, and from here it is going to pass 240 to the previous level. At every level we are having return statement, friends. Okay. So return 240. So this activation got also deleted. Afterwards again return 240. So therefore return value of this problem is equals to 240. Finally return 240. Right. What kind of questions we can expect from this topic? Again, focus on time complexity and space complexity, right? If you observe initially value of n is equals to how much? That equal to 4. N is equal to 4. And that 4 every time is multiplying with x. How long it is multiplying? As long as n greater than or equal to 81, it is doing the process. Okay. Maybe in the GATE exam, they may not ask time complexity based on this. They may ask how many number of function calls are there. Because time complexity point of view, there should be some relation, either it is n or n cube or n square or log n, like that. Okay. So whenever they are providing like this, they may ask how many times the function is calling, how many recursive calls are there. For example, same question they may ask the question. Here we asked about the value written by f of 4, right? Okay. They may ask the question how many number of function calls, because based on the previous year GATE question, I am telling all these points. Okay. How many number of function calls for f of 4, including initial call, So how many number of function call means we can say 1, 2, 3, 4 function calls are there, friends. Okay. The space complex, how many number of activation records are in the stack? 1, 2, 3, 4. So maximum depth of the recursion tree is 4. Maximum depth of the recursion tree is 4. Maybe they may ask the question like this: what is the maximum depth of recursion tree for this program? Max depth of recursion tree. That equal 4, because 4 activation code got created, right? That's why 4 is a max depth. That's all. So in this problem, I covered how storage class concept is combined with the control statement. In the previous program, I covered how control statement, storage class is combined with the control statement, that is for loop. Okay. And also we covered space complexity and time complexity in the previous program also, right, friends? Okay. Next one. Yeah, it is also same model question. That's the reason I don't want to evaluate. I will give time for you. You try. Okay, just try for this one. Return value of f of 6. It is also same model question. See here, condition, and we are having return statement, and again followed by return statement. So they are asking return value of f of 6, friends. Okay, if you are not getting correct answer, kindly listen. First input we are passing, that equal to 6. That is f of 6. When I call this function, the variable n will be created, which is known as formal parameter. N is equal to 6. What about this variable? Static variable, which already create into static memory during runtime, during compilation time of the program. So x is equals to 0. Let me create static variable x. Right, friends. Okay. After check the condition n less than or equal to 0, condition fail. Therefore, we can skip this line. N greater than 2, yes, 6 greater than 2, condition true. Therefore, we had to execute this complete block. Okay. So therefore, x is equal to n means content of n copied into x. Content of n equal to 6, that is copied into x. Afterwards, there is a return statement, there is a function call and addition operation. Now apply operator precedence table. According to operator precedence table, first function call will be executed, that is f of n minus 1, that is f of 5. Afterwards, addition operation, that equal plus 5. And then finally we can execute return statement. Now if I call function, the input is 5, then control will be transferred to called function where it is passing value equal to 5, friends. 5. Then again new variable n will be created. Create new variable n equal to 5. Now is this variable recreated and reinitialized? No, because static behavior, right? Therefore n less than or equal to 0, condition false. Now n greater than 2, yes, 5 greater than 2, condition true. So since 5 greater than 2, therefore content of n will be copied into x. So what is the content of n? That equal to 5. 5 copied here. Afterwards return f of n minus 1, that is 4 plus again 5. Afterwards you can use return statement. Now if I call this function by passing input is equal to 4, again new variable n will be created, n is equals to 4. As the base condition fail, n less than or equal to 0 condition fail, therefore you can execute n greater than 2, right? N greater than 2 means yes, n value equal 4, 4 greater than 2 condition satisfied. Again content of n copy into x, so that equals to 4. Afterwards return f of n minus 1, that is f of 3 plus 5, and then return statement. Next I am calling the input is 3, n is equals to 3. So next function call which is equal to 3. Again same story will be repeated. So, n greater than 2, yes, true. Therefore, content of n that equals to 3, copy into x. After certain f of n minus 1, f of 2 plus 5 and then return statement. Now, if I call this function with input is 2, right friends, okay. Now, n less than or equal to 0 condition fail. This time n greater than 2 condition also fail, right, n greater than 2 condition also fail. Therefore, we can execute return f of n minus 1 plus x. Therefore, f of n minus 1, that is f of 1 plus x and then return statement. Here we are having n is equal to 2, and next I am calling function with input equal to 1, right friends, okay. From here I am calling with input n equals to 1. Again new variable n will be created. Create new variable n is equal to 1, right. After creating new variable 1 greater than 2 condition fail. Therefore, again I want to call f of n minus 1 plus x, that equal f of n minus 1, that is f of 0 plus x, and then use return statement. Finally, I am calling with input is 0. Therefore, n value equals to 0 friends. N value equal to 0. Therefore, this time n less than or equal to 0 condition true. Therefore, return 1. It is giving back value equals to 1. Then this activation card will be deleted. Take the content of x in static location. The content of x in static location is 3. Therefore, take the value 3. 3 plus 1 4. Therefore, this return statement will return 4 to the previous level. Clear friends, okay. After this activation card also deleted. Take the value of x. What is the value of x? Value of x remain 3 only because of static behavior, right. So, therefore, 4 plus 3 that equals 7. This return statement will return 7 to the previous level, right friends, okay. So, this activation got also deleted now. Then 7 plus 5 which is 12. So, return 12 to the previous level. Then 12 plus 5 that equals 17, that will be returned to previous level. 17 plus 5. 17 plus 5 that is 22, right. 17 plus 5 which equals 22. Then 22 plus 5 that equals 27. So, it will return 27. So, I got answer is 27 friends, okay. Let me check what is your answer. So, 27 is the correct answer for this question. Yeah, let me explain because we do not want to waste time. See, if we consider it is a x variable, remember this is a addition operation and it is a function call, right. Function call will take high priority over addition operator. Therefore, this addition operator will be evaluated only after completion of execution of function call. Therefore, I am replacing, just observe here I need to keep x variable as it is only friends, okay, as it is. Do not take the value of x, because at this point of time, what is the value of x at this point of time? At this point of time, value of x is 6. Maybe you are substituting like this. Here it is substituting 6, right. Afterwards, here you are substituting 5, and here you are substituting 4, and here you are substituting 3 like this. You might be doing like that. If you are doing in that way, answer is 3 plus 3 6 plus 3 9 plus 4 13 plus 5 18, 18 plus 6 24 something you are getting. But is it the right process? No, right? Okay. What is the correct process for doing this problem? Kindly look at here friends. Here we are having variable is x. Here also we are having variable is x. Here we are having variable x. Here also variable x. The static variable will be evaluated only after completion of the called function execution, right. So, therefore, by the time you are coming back at this point of time, what is the value of x you need to consider. So, here x equal 3, x equal 3, when you are coming back at this point of time, what is the value of x? 3, because static variable created only one time in the static memory, it is holding previous stage values only. Therefore, what is the previous stage value? 3. Therefore, you can substitute here 3 friends, okay. Here also you can substitute 3. Here also you can substitute 3. Here also you can substitute 3. Earlier we had taken 5, 5, 5. This time we are taking 3, 3, 3. Clear? So how much difference is there? Obviously 8 is a difference because 4 3s are 12 and 4 5s are 20. So 20 minus 12 means 8 is a difference. Previous answer, what is the answer? 27. So 27 minus 8, that equals 19 is the correct answer. 19 is the correct answer. Clear, friends? Okay. If you understood the explanation, simply type U in the chat box, friends. Quickly type U in the chat box. Right. Very good. Now, what is the time complexity for this program, friends? Time complexity. Just imagine you are starting with the input is equals to 6. If the input value equals 6, how many times you are calling? Because the time complexity of recursive program always proportional to the or bounded by the total number of function calls, friends. Okay, total number of function calls. If you give input is 6, we are taking function calls 1, 2, 3, 4, 5, 6, 7 function calls are there. For input 6, 7 function calls, for input n plus 1 function calls are there. Therefore, the time complexity for this program is time complexity for this program is equals to theta of n plus 1, theta of n plus 1, because n plus 1 function calls are there. For input 6, 7 function call, for input n plus 1 function calls. But there is no importance of constant 1, therefore, we can make it as theta of n. Then what is the space complexity of this program? Space complexity is nothing but recursive depth, right? How much depth is there? Is the first activation record, second activation record, third, fourth, fifth, sixth, 7. It is also theta of n plus 1. Space complexity is equal to theta of n plus 1. That equal to theta of n. That's all, friends. Okay. So in this program, I covered how control statement if will be used within the recursive program, where the recursive program consists of static variables. So see how many concepts are there. Concept is recursion because function is calling itself recursion. It contains storage class concept, right? It also contains control statements. These are called comprehensive based questions. They're combining more than one topics in the same topic, friends. Okay.